Okay, good morning, everybody. This is Mr. Shua again coming at you with another math video. And this time we're going to talk about adding and subtracting rational expressions. And as you should know, a rational expression is simply a fraction that has polynomials in it. So what I'm going to do in this video is just show you how you should add and subtract these rational expressions here. I'm going to start out with some easy examples, then I'll go to some more complicated ones. All right, so let's look at our first one here. We have 1/7 plus 3/7. Well, the denominators are the same, so this one's pretty simple. So 4/7 is our answer. Okay, whenever the denominators are the same, these work out pretty easily. Okay, let's look at our next one. We have a 2x plus 1 over 7 plus a 4x minus 5 over 7. Now, since our denominators are the same, 7, all we need to do is just add our numerators. So 2x plus 4x give me 6x, and then positive 1, negative 5, 6x minus 4 over 7. But then I can factor a 2 out of both terms. So that's going to be 2, parentheses, 3x minus 2 over 7. Again, that's another simple one. And then let's go on to our last simple one here, number 3, where we have a 2x minus 6 over x minus 5. And this is minus 5x plus 7 over x minus 5. Again, our denominators are the same, so we keep the denominator. Then we just work with the numerators. Well, 2x minus 5x is a negative 3x. And then negative 6 minus 7 is negative 13. So it works out to be a negative 3x minus 13, but since the negative is here, we simply just move the negative to the side. Okay, so those 3 examples are pretty easy because they all have the same denominators. So let's look at some examples where the denominators are not the same. All right, come on, move down. Okay, let's look at number 4 here. So number 4 is 5x over 6 minus 3x minus 4 over 8. So here we have a denominator of 6, we have a denominator of 8. Those denominators are not the same, so we have to make the denominators be the same because we can only add and subtract polynomials when the denominators are the same. So what I would do in this instance, this first fraction, 5x minus 6, I would multiply it by this denominator, 8 over 8, which is just 1, correct? But when I do that, I'm going to get a denominator which is going to be the same as the next one. Here, the 3x minus 4 over 8, I'm going to multiply by 6 over 6, which is just 1. Notice I'm multiplying both fractions by 1, but the way that I'm multiplying by 1 gives me the same denominator for both, because 8 times 6 is the same as 8 times 6, right? So my denominator is going to be 48 for both of them. So now let me work with our numerators. Now 8 times 5x, that's 40x. And then a negative 3x minus 4. Here, 6 times 3x, that's going to be 18x. 6 times negative 4, that's 24, negative 24. So in my numerators, I have 40x minus 18x minus 24. They're both over the denominators of 48. Now, all I need to do, since the denominators are the same, just work with the numerators. So 40x minus 18x is 22x, and then the minus negative 24 is a positive 24. So that's 22x plus 24 over 48. This can be simplified because 2 goes into all of them. Your final answer, 11x plus 12 over 24. All right, that one was fairly easy too. Let's look at this next example. A little more complicated. We have negative 4 over x minus 5 plus 5 over x plus 3. Again, x minus 5, x plus 3, 2 different denominators. So I need to work to make the denominators the same so that I can add or subtract them. So what I would do is I would take this first fraction, the negative 4x minus 5, and I multiply by this denominator, x plus 3 over x plus 3, which is just 1. Right? Then I would just take the 5 over x plus 3 and multiply by this denominator, x minus 5 over x minus 5, which again is just 1. See, but when I do that, when I multiply each fraction by the other fraction's denominator, notice that my denominators are going to work out to be the same thing. My denominator is going to be x plus 3 times x minus 5 here, and x plus 3 times x minus 5 here. So they both have the same denominator. Now I'm going to work with my numerators. So x plus 3 times negative 4, that's going to give me the negative 4x minus 12. And then the 5 times x minus 5 is going to give me a 5x minus 25. And notice both denominators are the same. So now, since the denominators are the same for both the fractions, all I need to do is combine my numerators to get my answer. So negative 4x plus 5x is just x, and then negative 12 minus 25 is minus 37. So final answer, x minus 37 over the denominator x plus 3 times x minus 5. Okay, I have one more example to show you, a little bit more work, but it's still rather simple to solve. All right, let's take a look here. We have a 5x over x squared minus 25 minus x over x plus 5. Again, x squared minus 25, x plus 5, different denominators, but we notice the x squared plus minus 25, that's a difference of squares, and that can be factored. And that basically factors to be x plus 5 times x minus 5. So the denominator here, x plus 5 times x minus 5, the denominator here is x plus 5. So notice we're missing an x minus 5 in the denominator here. So what I would do is multiply the second denominator by x minus 5 over x minus 5. Notice I don't need to multiply this first fraction by anything because it already has the denominator that we need, right? So now, when I multiply the second fraction by this x minus 5 here, that's going to give me x times x is x squared, and then the x squared times the negative 5 was negative 5 over x. But actually, we have this negative sign here. So it's actually negative x times x, which is a negative x squared. And then negative x times negative 5 is a positive 5x. So our first fraction gives us a 5x. And then multiplying the second fraction with that negative sign gives us a negative x squared plus 5x. And notice that my denominator is the same for both, x plus 5, x minus 5. So now, all I need to do is combine the numerators since my denominators are the same now. And then I'm going to place it in standard form. So the 5x and the 5x are going to be a 10x. I just moved the negative x squared to the front, negative x squared plus 10x. Now notice I can just basically factor out a negative x out of the numerators here. If I factor that negative x out, I'm going to have an x minus 10 here. And with the negative, since the negative is in the numerator, I'm simply moving it outside because it doesn't matter whether your negative sign is in the numerator or the denominator, it makes the fraction negative. So the final simplification, negative x times x minus 10 over x plus 5, x minus 5. Okay, so hopefully that helped you with your adding and subtracting rational expressions. And it doesn't matter if it only has 2 fractions or 3 fractions or more. You basically go about these steps the same way. Mr. Shua again, and hopefully this video helped you here. And good luck on your next quiz or test, and I'll see you on the next video.